Link parameters and dimensions. In this video, we'll link model and user parameters in the parameters dialog. We'll link user parameters to a sketch dimension, and we'll identify a fully defined sketch icon. In Fusion 360, we want to carry on with our gear reduction housing. If we had any difficulty, you can also go in and upload the supplied dataset Gear Reduction Housing v2. This should contain all of the user parameters that were created based on our spec sheet. You can see here that this also includes our mounting bolts, idle gear shaft, mounting bolt flange, as well as our gear clearance value. To get started, we want to begin by creating a new sketch, and we're going to be selecting the X, Y, or the front plane. We're going to begin by using our center diameter circle. I'm going to draw a large center diameter circle, and you'll notice that the dimension box is currently highlighted in blue. If I begin to type in a value, I can enter, for example, G, or I can enter the letter D, and it brings up all of the various user parameters that we created. You will note that it doesn't show the actual value of these, but it does show whether or not it has a value or if it's unitless. So in this case, we're going to be creating our drive and our driven gear both at the center or the origin. So I'm going to start with the drive gear, and then I can left click to place it. This will allow me to stay on my circle tool. I can draw a second one, and I can hit the letter D, and this time I'm going to be using my driven. And again, I can left click to place that value. And then I want to begin drawing a few additional circles inside of here. These are going to be my idle gear diameter. I'm going to draw another one inside of here. And if you forget to place that dimension, that's okay. We can always go back and add it. This outside one here, and then I'll hit escape to get off my circle tool. If we need to go back and place a dimension, we can use the dimension tool, select, and then as it's asking for our input, we can hit that I on the keyboard and have it automatically linked to that idle gear diameter. The next thing that we want to do is we want to apply a few constraints. I'm going to begin by using horizontal vertical. This is between my origin and the external idle gear. Next, I want to go to my tangent constraint, and I'm going to make all of the idle gears and the gears on the inside tangent. You'll notice that when I do this, I'm going to have to make sure that I hit escape on the keyboard to get off my constraint tool and make sure that things can still move around. Once they are able to move around, I'm going to go back, left click to make sure nothing's selected, go back to my tangent tool, and then I'll place a tangency between the outside here. Can hit escape on the keyboard, and notice that it's still free to move about. I haven't actually created a fully constrained sketch yet. If I expand the sketches folder, let's make note of the icon next to sketch. I'm going to take the center of my second idler, I'm going to control or command select the origin, and then I'm going to use my horizontal vertical. As soon as I do that, all of my sketch elements turn black, and the icon changes from a pencil to a small lock. This is telling me that I have a fully defined or a fully constrained sketch. From here, I'm going to finish the sketch. I'm going to go back to a front view, and I want to talk for a second about each of these gears that we drew. These are going to be placeholder positions to get us a good idea of where all of our gears need to be. We have our drive and driven gears at the center. Our final assembly will have a common shaft that allows us to drive one of the gears and then have a bearing so that the other gear is free to rotate. We'll transfer power from the center here, moving over to our first idler gear, which will change its direction to counterclockwise. As we move to the second idler, this one will change to clockwise, and as we get to the third idler, it'll change again to counterclockwise. As this one is rotating counterclockwise, it'll rotate the large gear clockwise. So using this idler strategy and having 3 separate gears allows us to create the correct rotation of our input and our output. Remember that we are talking about our drive gear being our large gear and our driven gear being our small gear. But it is important to note that this type of assembly can work in either direction. We can have our input be on the smaller gear, which would allow us to reduce or increase the torque and speed. Now, I say reduce or increase. It's because depending on which side is our input and which side is our output, we're either going to be increasing torque and reducing the speed, or we're going to be reducing torque and increasing the speed. So, again, it's important to note that the input and the output can vary depending on how we want to use this assembly, but we are considering our large gear to be our drive gear, and the small gear is going to be our driven, and all the smaller gears here are going to be our idlers. So, from here, we want to rename our sketch. We're going to do this by selecting it, left clicking on it one more time, and we're going to call this our layout sketch. Renaming our sketches is an important step in the process, especially once we get a few sketches inside of this folder. It's going to be much easier for us to identify what that sketch was used for. If we hover over the sketch icon that's inside of the timeline at the bottom, you can also see that the name does appear. Layout sketch is shown there, and it's inside of our gear reduction housing. From here, let's make sure that we do save this design before moving on.